How can a continuous outcome be predicted from several variables? An important supervised machine learning technique called multiple linear regression can achieve this. In this presentation, it is used to predict house prices from 4 other variables. Welcome to my YouTube channel where I discuss topics related to data science. The presentation begins with the basic concepts of multiple linear regression and key assumptions. Multiple linear regression is then applied to the prediction of house prices using 4 independent variables. Finally, the complete implementation is demonstrated in Google Colab using Python and the scikit-learn library. Multiple linear regression is a type of supervised machine learning. In supervised learning, the model learns from labeled data where the desired output is known. When the output is a continuous numerical value, the task is known as regression, with a potentially infinite range of possible values. This contrasts with classification, where the output belongs to one of a finite number of predefined classes. Linear regression attempts to describe a linear relationship between the input and output variables. In simple linear regression, there is one explanatory variable and the relationship can be represented by a straight line. When the model is extended to include more than one explanatory variable, it becomes multiple linear regression. The underlying concepts and approaches to model evaluation remain similar. Several assumptions should be considered when applying multiple linear regression. A linear relationship is assumed between the predictors and the dependent variable, while strong correlations among the predictors should be avoided. The variance should also remain reasonably constant across the fitted values. For normality, at each combination of values of the independent variables, the dependent variable is assumed to be normally distributed. The errors should also be independent of each other. Finally, although checking for outliers is not itself a formal assumption, unusual observations should be examined because they may strongly influence the fitted model. The objective of linear regression is to estimate the coefficients that minimize the differences between the observed and predicted values. Scikit-learn's linear regression class solves this as an ordinary least squares problem. Unlike gradient descent-based approaches, the standardization of the variables is not normally required. The resulting coefficients can then be used with the predictor values to obtain the predicted response. Different computational approaches can be used to solve regression problems. The SVD-based least squares approach is efficient when the number of predictors is manageable, but becomes more computationally demanding as the number of predictors becomes very large. Stochastic and mini-batch gradient descent can be useful for large problems. However, these approaches introduce hyperparameters and generally require scaling of the variables. The Python implementation begins by importing the required libraries and loading the house price dataset. The dataset contains 10,000 synthetically generated observations with price as the target and 4 independent variables. Initial exploratory data analysis includes checking for missing values and using a scatter plot matrix to examine the distributions and relationships among the variables. The predictors and target are then separated in preparation for model development. The dataset is subsequently divided into training and test sets. The multiple linear regression model is fitted using the training data, and the fitted model is then used to predict house prices for the test set. Model performance is evaluated using the R-squared score, while the estimated intercept and regression coefficients are also obtained. Finally, the actual and predicted test values are visualized together with an ideal prediction line. The complete Python workflow from importing the data to visualizing the results is summarized here. The exact code for implementing multiple linear regression in Google Colab is shown. The commonly used libraries are first imported, including pandas and numpy for data handling and matplotlib for visualization. The other relevant modules are imported later. The CSV file is then loaded into a pandas data frame. The dataset shape attribute provides the number of observations and variables, while the head function on the dataset allows the first 5 rows to be inspected. As part of the exploratory data analysis, the dataset is checked for missing values with the null function. Then, the scatter plot matrix function from the MLX10 plotting module is imported. A scatter plot matrix is then generated to examine the distributions and pairwise relationships among the variables. The X predictors and target Y are first separated, with the final column representing house price. The data are then divided into training and test sets, with 30% reserved for testing. A value for random state is set to ensure reproducibility in the splitting of the dataset each time. The linear regression class is instantiated and fitted to the training data. Predictions are subsequently generated for the test set and displayed alongside the corresponding actual values. Finally, the R-squared score is calculated to evaluate the model. The fitted regression is then examined. The intercept is first displayed, followed by the coefficients for the 4 independent variables. Next, the actual test values are plotted against the predicted values using a scatter plot. The alpha value is set to 0.6 to make the points slightly transparent, which helps when observations overlap. Next, the minimum and maximum values across both the actual and predicted values are obtained. These values are used to draw the dashed ideal prediction line. Along this line, the predicted value is equal to the actual value. Therefore, the closer the data points are to this line, the better the agreement between the predicted and the actual values. Finally, the axis and title are labeled, the legend is added, and the scatter plot is displayed. The scatterplot matrix obtained provides an overview of both the individual distributions and the relationships between pairs of variables. The most obvious pattern is the strong positive relationship between square footage and house price. The relationships between price and the other predictors are less apparent from the individual scatter plots. The plots also provide a useful initial visual assessment of the data before interpreting the multiple regression results. The results of the multiple linear regression model are shown here. The fitted regression equation includes an intercept of approximately 531.68 and coefficients corresponding to the four independent variables: square feet, number of rooms, age, and distance to the city. Some of the actual house prices and their corresponding predicted values are shown on the left. The scatter plot provides a visual comparison of the actual and predicted values for the complete test set. The dashed red lines represent the ideal prediction where the predicted value is exactly equal to the actual value. Most of the points lie close to this line, indicating good agreement between the predicted and actual house prices. This is also supported by an R-squared score of 0.959, indicating that approximately 95.9% of the variance in house prices is explained by the four independent variables. The multiple linear regression model performed well on this data set. Approximately 95.9% of the variance in the house prices was explained by the four independent variables, and the predicted values showed close agreement with the actual values. This presentation has demonstrated both the underlying concepts and a practical implementation using scikit-learn. In next presentation, another regression approach will be applied to the same prediction problem with support vector regression and stochastic gradient descent being among the possible approaches to explore. The complete implementation of the code in Google Colab is shown here for further reference. As usual, before running the code, the CSV file containing the dataset is first uploaded to the Google Colab environment. These resources provide further discussion of machine learning, regression, and related data mining methods for those interested in exploring the topics covered in this presentation in greater depth. Thank you for your time. Keep exploring, keep questioning, and keep turning data into knowledge. Please subscribe to keep updated with new videos, and I would like to be pleased to see your comments and suggestions.